so let's do consumer math. Now it's getting hot in here, no? All right, so let's do this. So chapter 8. So additionally, one of the reasons I spend so much time on this is because I've talked to different professors in the business department, which I think some of you guys are business majors, right?
Yes.
Or possibly. And they say, a lot of people say that the math issues that people face is percents going to decimals and different applications of formula, how to compute those. So again, that's why we spend so much time on this. So section 8.1 is percents, taxes, and inflation. Okay, so first we'll talk about percents. So write each decimal, or each percent as a decimal. Okay, number 1, 30%. So 30% I cannot type into my calculator, right? So how do I write 30% as a decimal? Pardon? So I move the decimal place over twice. So this is 0.30. So that's my decimal representation of my fraction. But 3 over 10 would get you there. How do I write 125? 125% as a decimal. Well, I still move my decimal place to the left twice, and that's it. I don't care what number I get. If it says something something percent, I'm moving my decimal place to the left twice. And then I can use that number to put into my calculator. Number 3, 13.2%. So again, I don't care what my number is. I'm moving my decimal place to the left 2 times. So this is 0.132. Don't round. Mm-hmm.
Did you do number 2, right?
Yes?
So
Why?
if you move it to the right twice, how is it still 1.2?
No, you move it to the left twice.
Oh, okay. Sorry, that's on me.
No. But make sure you get your questions answered, so good. So whatever, if there's the percent symbol and I want to write that percent as a number, no matter what the number is, I move my decimal place to the left twice. I think I just heard on the radio that the government is discussing a 0.25% tax increase. Or, I mean, sales tax increase. 0.25% sales tax increase. Can somebody help me write that as a decimal?
0.25.
So that's 0.25%. That's 0.25%. That's 1/4%. So I'm going to write this as equals 1/4, 0.25%. 1/4 is 1/4%. Okay, how do I write that as a decimal? So that's translating the news article into the percentage, okay? Now, no matter what, if there's the percent symbol, I'm moving it to the left twice. So it's 0.0025. Good. I don't care what my number is. All I care is if there's a percent symbol, I move the decimal place to the left twice, and that's it.
So that's how much tax is going to go up?
Sales tax. Yeah, so if you buy something, it's going to cost you 0.0025.
When is this going to decide?
I think they're talking about it, voting on it. They're discussing the sales tax increase because that sales tax increase, they could take that money and spend that money towards schools and arts and science developments in education.
Yeah, it does.
Is that a state thing or is that a?
I don't know. I just heard it on the radio, so I can't say for sure. It might just be a Mecklenburg County thing. I'm not sure.
How about the schools in Chicago? The teachers are going to make like $100,000 a year.
In Chicago?
Graduation rate's still going to be like 15%.
So I lived in Chicago. I did my student teaching in Chicago. One of the rules, if you want to be, it's also CMS, Chicago Public Schools, or CPS. If you want to be a teacher in CPS, you have to live within the city limits. So you also have to be able to afford to live there, right? So keep that in mind, right? So it's not just that they're getting paid so much more, it's that the living expenses are much more too. So I do think, but that's why I think I talked to you guys about, so I think usually how much teachers are paid is regulated by the state typically, right? Yeah, public school is regulated by the state. So think about people who teach in the suburbs. If there are incremental increases that are defined because it's a state, it's a government job, then no matter where you live in Illinois, it should be the same. It should be the same pay scale. That's why I told you guys, like my dad retired making very good money when he was a teacher for 30 years.
What did that teach you?
He was a guidance counselor, but his degree was in English or something.
Cool.
I think teaching is a very honorable profession, though. Okay, so do you guys feel comfortable changing percents to decimals? Yes. In the business department, they say people cannot do this. We did 4 examples. Can you do this? Do I need to do more examples?
Yes.
More examples?
No.
If what?
1/4 would be 25%.
Yes. Oh, 1/4 is 25%.
Yeah. So it shouldn't equal 1/4 of a percent.
Oh, yeah, so thank you. Yep, you're right. 1/4 is 25%, yep. So it's 1/4 of 100%. Thank you, Aiden. That's very good. Oh, that's really good. So move it to the left twice here. Very good. I think I converted it, and
Yeah.
sometimes I tell the answer when I'm asking a question.
No, that keeps going up by 25 cents.
0.25% of a cent. It's not just 25 cents. Okay, so are we good now?
What's 0.25% of $1 billion?
Put it in your calculator, 0.25 times a billion. Okay, so, well, the point of that example, I was trying to give you a contextual question, but what if we have this as a percent? I don't care what the number is, I still move it to the left 2 places, right? So I have 3 zeros, 2. Okay, so we're good with this? Okay, so now let's talk about some equations. Percent change. So here's an equation, the percent change equation equals new amount minus base amount over base amount. Bless you. So that's a formula you need to memorize. So sometimes I write this equation. I think the English part is important, but I usually write percent change equals new amount minus base amount over base amount. But obviously you have to know the N and the B. Okay, So previously when I've taught this section, the thing that some people struggle with is figuring out which is the new amount and which is the base amount. So we're going to look at that in terms of time. So new versus base. So we're going to look at the new amount versus the base amount in terms of time. So time is linear, right? So new base. If I give you a question like, 10 years ago your home cost this and now your home costs this, or your home has increased by whatever percent. 10 years ago, oh shoot, sorry, it's the other way. I need to drink more coffee. Base, new. So base is your older amount and your new amount is your either future or current value. So let me write this on the other page. So if you have a question, you could have your previous amount and your current amount. So this is in terms of time, right? Time is linear, right? So base amount is your older amount, and your new amount is your so here we have previous and current value. Your previous would be your base, and your current would be your new. Here we have current, and here we have future. So in your word problem, you have to distinguish between what's your new amount and what's your base amount, and I think that that's people's biggest problem is saying what's new and what's base. So your previous value and your current value. Your previous, because time, this is the older, this is the newer. Here, if you had a question like current value, future value, your current would be your older amount, and your future would be your latest amount.
So base is always the oldest?
So base is always the oldest, and new is always new. Yeah, I don't know how to explain it without saying new, but yes. So, but you think about time as linear, right? So your base is the oldest amount, and your new amount is future value, current value. If you had time like in 1955 and 1970, right? So this is time, your older amount, your newer amount. Whatever that is, whether it's future, whether it's current. But I think this, having questions where you have the current amount in each, I don't know, messes with people. But this is how we're thinking about new versus base. Okay. So base amount is previous amount. Okay, so let's do an example. So this is example 6. So a lot of these are going to be word problems, so get ready for it. What are you guys doing back there?
I dropped something. Put it in my pocket.
You guys are like playing footsie back there or something. I don't know what's going on.
You stole my pencil. So I did that.
Huh?
You stole my pencil. So I did that.
Yeah, what are you guys doing?
Ask him. You stole my pencil. You're studying my education.
Okay, so assume a 12-pack of Red Bull.
You would die.
What?
You would die.
Okay.
You
So
drank the whole thing Red Bull?
assume a 12-pack of Red Bull costs.
They only sell 12 packs. 4 packs on there.
Dude, I don't know. Okay. I think the example was not Red Bull. It was a 12-pack of something else. So I'm trying to make it friendly. I don't know what to say. Of Red Bull cost $18.02 in 2010 and $19.58 in 2015. What is the percent change in this time. Another way to ask this is, what is the percent? So without explicitly saying percent change, right? Because on the test, it's not saying, hey, use this formula. Hey, use this formula. On the homework, it's not going to say, use this formula, right? It's saying, what percentage has the cost increased over time? That's a way to ask you without telling you to do percent change, right? Okay, so now we need to look at this and identify the pieces of our function, right? We need to identify new amount and base amount. So again, we said the time is linear. The base amount is your oldest value. The new amount is your newest value. So we need to figure out what that is. So what do you guys think with in terms of this, how we described it? So here is my older value. 2010 is my older value, so this is my base. And then $19.58, that's my most future in terms of time, right? Okay. So solution. Okay, so I'm going to write down my equation, right? If it's a test and you can write down the equation, that's awesome. So percent change equals new amount minus base amount over base amount. I hope everybody starred that you need to have the formula memorized, right? So here we said our new amount, so percent change. So, right, if you have an equation, you should only have one question or one of these letters or words that you do not have a value for. If I don't know the base amount and the new amount, I don't care what the percent change is. I can't solve for that, right? The point is that all of the questions in this section should be linear equations. That means an equation with one variable to the first power. That's why we spent time previously solving linear equations. So percent change equals new amount, 19.58, minus base amount, 18.02, over base amount, 18.02. This I can put into my calculator.
Equals 0.0865.
Okay? Equals 0.0865.
Yes.
Okay? What do you guys think?
Well, I didn't do it that way. I did 19.58 minus that and then divided it.
By what?
I got 11.55.
Okay, so I'm going to show you what you did. So 19.58 minus 18.02 divided by 18.02. Is this what you did?
Yep.
So you're dividing this by this. You're not dividing the entire numerator over this. So you're saying 19.58 minus 1. Right? So if you do put this into your calculator, you have to do parentheses here. Parentheses around the entire numerator divided by the denominator. If the denominator had some other stuff, do parentheses in the denominator. Okay? This is the answer that I wrote down.
So will I need to say the forces?
What?
Will I use a scientific notation calculator for this test?
I don't know. I think we might get to stuff where we need exponential or log, right? I told you guys you had to have a calculator that has the log button. So I think we might have to use it, but
What is a log button?
takes the log of something, takes the natural log of something. So log is like a function. Do you know sine and cosine? So it's kind of like you can put something into those functions, right? You can take the sine of something. Here you can take the log of something. And it's really helpful with compound interest and stuff.
What's the other one? There's sine, cosine, and
Tangent, cotangent, secant, cosecant. Okay. So do you think we're finished? Huh?
Yes.
No. No. So this is percentages. Here I have a decimal, right? So how do I change a decimal to a percent? Before we did percents to decimals. Now we need to do decimals to percents. Multiply it by 100, which means move the decimal place over twice to the right. So this is 8.65%. So that's the answer. Okay? All right, you guys ready to write some more? So is that clear? Really what we need to do is we need to identify the pieces we have in the question. I like to underline them. Here, base versus new, time is linear, so that's really the only trick. But in this section, we're going to do a couple different formulas, so you really have to know which formula you're looking at. This one explicitly said, what is the percent change? But a better way to ask this on a test is to say, what percent has the cost increased? That doesn't explicitly say percent change. But it's the change in the cost of something over time, the change in the value of something over time. That's when you use this formula. Okay, number 7. A car store is having so I'm just going to write all of this stuff. A car store is having an end-of-year clearance which claims that all cars are sold at a 5% markup over the dealer's cost. A new Honda is for sale for $23,302. You find the dealer's car to be $21,339. Is the dealer being honest? So this one doesn't relate to time as much, right? But a little bit, right? What's happening first? Is the dealer buying or selling the car first? Buying, so that would be your base amount, right? They've marked it up, they've changed the price. So this is your base amount, this is your new amount. Does that make sense? Okay, so let me underline. So this is base, this is new. So again, it does relate to time a little bit, right? This is what they bought it for, and they bought it before they sold it. So what do we need to check? What do you guys think? What's your intuition for this? Because I also have the percent, right? So is the dealer being honest? What do you guys think? I have all 3 pieces of the formula, right? But what do I really need to verify?
But you're trying to see if he actually went up 5%.
Okay, so how do you think we should go about this problem then?
The new minus the base, and divided by the base of old.
So you want to compute the percent change and see if that equals 5%. Is that what you're saying?
Yeah.
Yeah, I think that's a good idea, right? Do new minus base over base and see if that equals 5%. What's your guess about, do you think it's going to be 5%? Do you think it might be more, might be less? I don't think it's going to be less, right? Nobody's saying I'm only marking it up 5% to give you the best price. And then they're not, and then they're only marking it up 1% because they'd sell that to you, right? They tell you that. So percent change equals new minus base over base. So this equals new, which is 23,302 minus 21,339 over base, which is 21,339.
Which equals 9.19. 0. Well, if you want me to give you the decimal as a percent.
So I have the answers.
Okay.
So I want to make sure that we understand the formula and we understand where to plug it in, right? The deal is that if you can write out the formula you're using, if you can identify the pieces in the problem, that's probably 8 out of 10 points, right? The actual answer is usually 1 point, right? If you plugged it into your calculator and you got something a little wrong, that's usually 1 or 2 points. If you set up the formula wrong, if you don't know the formula, that's the bulk of the problem. So we need to make sure we understand this and we're showing this work on the test. Okay, so Aiden, you got 0.0919?
Yes.
Okay, not our final answer because it's not a percent.
Becomes 9.19%.
Percent. Okay, so what do you guys think? I didn't answer the question yet, right? What's the answer to the question? No, the dealer's not being honest. He's saying he's marking it up by 5%, but he's actually marking it up by over 9%. Not being honest. Okay. So now we're going to move on to another equation, and we'll do a couple examples from that, but then we're going to do a bunch of examples where you have to determine the equation to use. Okay? So this is C, percent equation. So this is percent times base equals amount. So examples. Number 8. What is 35% of 140? Okay, so let's go through a little math to English translation. So we're trying to plug it into this formula, right? We need to identify what pieces go here. In English, what does of usually mean? Multiply. What does is usually mean? Equals. Look at this equation. We only have a couple symbols. Okay, so let's translate. What percent, okay, so what percent what is 35% of 140? Somebody help me write that. What's 35% as a decimal? 0.35. I moved the decimal place over twice. 35% of 140 equals, question mark, right? Equals, in this, here we say amount. So we're just translating. Here you could say what amount equals, but I was trying to make it look like this equation. So 35% of multiplies 140 is the amount. So I just did the opposite order, but that's okay. So now I put this into my calculator and I solve. What do you get? What is it?
49.
49 is the amount. Okay, next. You good with this? Okay, so 63 is 18% of what number? Okay, so let's translate this to math. So 63 is equals 18%. How do I write that as a decimal? What is it? Good. Of what number times, and I'm just writing the words from this equation above. So you could write base, you could write x, you could write whatever. Okay, I'm going to leave it as a capital B for base. All right, what kind of an equation do we have now? It's a linear equation. I have one variable raised to the first power. That's why we spent time reviewing how to solve linear equations. If you struggled with that before, make sure you know how to do it now. Okay, so how do I solve this? This is a number times b. I want b equals, right? So divide. The opposite of times is divides. So I'm going to divide. B equals, what is it? 350. Good. Okay, let's do another one. So 288 is what percent of 640? All right, so try to translate it on your own. Translate it to math. Like how we're talking about math, like it's a different language. It's okay. Thanks. Okay? Somebody help me set up the equation.
2 divided by 640.
I want it set up like this, directly from the words to the English. Is equals what percent? I don't know. Percent. I'll make it P, so it's not the percent symbol. Is what percent of is what operation? Times 60, 640. Okay, linear equation. I have one variable to the first power. I need to get that variable equals a number, right? So this is P times 640, so I'm going to divide both sides by 640. And I get P, and that's because 640 over 640 equals 1. Okay, so what's this? 45.45. That's what you got, right?
Yes.
Okay, it says what percent, not what decimal though, right? So it's 45%. So make sure you're actually answering the question, right? All right, how do you guys feel about these? You just have to translate it to English. Is equals, of is multiplies. All right, do you guys want more examples like this? I'm going to do it because I always get people that answer these questions incorrectly, which makes me worried about when we do word problems. 12 is what percent of 80? I keep doing the percent instead of the question. So translate it exactly how we did before. P times. I'm trying to do that as times. I'll do the dot. Divide both sides by 80. Whatever you do to one side, you have to do to the other side. And what do you get? P equals, what is it? 0.15. Good. So am I finished? No, because it says what percent. I don't want the decimal, I want the percent. 15% equals P.
Will it ever want a fraction?
We always talk about decimals either like, or percentages like this or like decimals.
Okay.
I mean, I did hear 1/4%, right?
If you were to just simplify that and you made it 3/20, would it come out with the same answer?
If you simplify correctly, it should, right? But you shouldn't simplify because it should be as a decimal.
Right.
So that's like an extra step. And sometimes if you do extra steps, it's more likely to,
Right.
make mistakes, right? All right, 12. What is 24% of 125?
24 equals.
Okay, let's let everybody have a chance.
Okay.
And then maybe I'll call in some other people so it's not just me and Aiden. Who can help?
Say 25. 25 equals.
What do you guys think?
All the other factors, yes, 24 equals 25.
Okay, so let's translate it exactly, right? So somebody tell me again the English words that I'm looking at. Is equals, of is multiply. Okay, so what is, what is, I don't know, we'll call it the amount, is 24%. Change that to a decimal. What is it? 0.24. 0.24. 0.24. Of is multiplication. So I'll do the dot. Of 125. What is it? 30. Bless you. So really, that's why I think it's really important the first time to just translate exactly how you see it, because I think a lot of people tend to see these things different ways, but if you're not translating it correctly, then just try to do is equals of multiply. So 13. 77 is 22% of what number? All right, somebody help me.
Yeah, I'll help.
Perfect.
Let me write it down first.
All right, you can help with the next one. Who can help now?
What was gonna be the next one? Alright, I got you.
Okay.
Uh,
So translate exactly from the question to the...
77 equals 22%, 0.22 times
We'll call it B.
B.
What do you guys think? Is equals of multiplication what number? That's the question. That's what we're looking for. So 77 equals 22%. You change it to a decimal of what number? Good. All right, how do I solve this? Divide by what? 0.22. Divide by 0.22. Good. Because I have 0.22 times B. What do you get? Good. You want to do one more? Are you guys good? Good. Okay, let's do a word problem then.
I think you're losing the enthusiasm.
No enthusiasm.
So at one time, the 95-96 Bulls had the best had the best record in the history of the NBA.
You a Bulls fan?
I really only like college basketball with 72 wins. I mean, I lived in Chicago for a long time, so that's the Chicago team, but I mean, they're good, but I don't know.
Not last night, they weren't good.
Yeah, I haven't watched them in a long time,
Yeah, it's interesting.
so I'm definitely not as big of a fan as everybody else here. That was like, pfft. Okay, so at one time, the 95-96 Bulls had the best record in the history of the NBA with 72 wins and 10 losses. What percent of their games did they win? So what percent of their games did they win, right? That's the question. So I'm obviously looking for a percentage. Okay, Hayden, you have an idea?
Would it be 72 equals P times 82?
So 72 equals P times 82.
Divide it.
What do you think?
Then divide by 82.
Yeah, divide by 82.
So this is 72 is what percent of 82? You guys think that's good?
Because if they're
Where'd you get the 82 from?
Because 72 plus 10.
So that's the total games. So that's like the whole amount of games. So we're saying 72 is what percent of 82? 72 wins is what percent of the total number of games? So what percent of the games did they win? So 72 is what percent of the total number of games? You guys think that's good?
87%.
I think that's good, right? But the equation makes sense. A lot of times, taking the information can be challenging. Do you guys see where all this stuff comes from?
Yes.
Okay. What do you think, Jake? Y'all need some coffee today or something.
Yes.
You get a coffee machine if you're
I see Dunkin' Donuts one day.
Who's bringing? All right, so this is a linear equation. I have one variable with one exponent, right? So to solve that, I have P times 72. So the opposite of times is divides. Okay. P equals, what's 72 divided by 82? That's not what I got. 0.878. So am I done? I'm not done because it's not a percent. So this is 87.8%. So they won 87.8% of the games they played, right? So we've answered the question. We're good. Okay. That's that, y'all.